Hello everyone, this is Balu. Welcome to my channel Civil Cave. In this video, I am going to discuss about eccentric in-plane welded connection. Here you can see this is the load of intensity P which is acting at an eccentricity E, and whatever the load and also the weld, both are in the same planes. So that's why we are calling it as in-plane connection. If you assume whatever the board which you are seeing is a plane, and coming to the load and also both the welds are in the same plane, so it is nothing but in plane connection. Now how this load is going to be transferred to this weld, in this video we are going to discuss about that. I am discussing about whatever the eccentric connections, because it is very important for the people who are working in the industries, especially for the steel structures. So let us get into the video. And if you have not yet subscribed my channel, please subscribe my channel and also click the like button and also share with your friends who are working in the civil engineering field. Now in the similar case, whatever we have discussed in the bolded connection, I am going to apply load of magnitude P in both the direction, that is from the top and also from the bottom. And if you combine both these conditions, you are going to get the initial case only. So to convert this whatever the eccentric load into the torque and also shear, I am going to add whatever the load in the both the directions which is of equal and in opposite direction. So here you are going to get the whatever the torque you are going to get, which is of the magnitude, that is P into E, because of this two equal and opposite force at an lever arm E, and coming to the remaining force you are going to get shear is going to act on the weld, and it is going to pass through the CG of this weld CG. So now let us get into the calculation part. So this is nothing but the shear which is going to act, and also the torque is going to act across this weld. And if you convert whatever this weld separately, this is the cross section. You are going to see that whatever the weld cross section, and x bar is the centroidal distance, and coming to the r, which is a radial distance from the CG of this weld to the extreme fiber of this weld. Now coming to the derivation part, whatever the load which is acting, that is nothing but shear and also the torque. Why I am calling this as torque? Because it is going to rotate the weld cross section. So it is nothing but torsional stress is going to be generated in this weld. And coming to the torque, which is of intensity P into E. Let us derive regarding this direct shear stress. It is nothing but load by the area. Area is nothing but the whatever the welded area, throat thickness into the length of this weld. That is A is the dimension of the weld and also D is the dimension of weld, and total length is nothing but 2A plus D. And coming to the throat thickness, K into S, K is the constant which depends on the angle of fusion faces. 60 degrees to 90 degrees basically it is considered, and for this 60 degrees to 90 degrees, K is nothing but is the 0.7, and S is the size of the weld which depends on the plate thickness. And coming to the torsion equation, T by IP, T is nothing but torque and IP is the polar moment of inertia. Tau is nothing but the torsional shear stress, R is the radius, and coming to N, rigidity modulus, theta is the angle, and coming to the L, the length. Now I am going to derive for the torsional shear stress. The tau is nothing but T into R by IP. IP is polar moment of inertia, and torque is P into E into radius divided by the polar moment of inertia. Now, polar moment of inertia, you all know Ixx plus Iyy. For example, this is Xx and this is Yy axis. And if you are going to combine this Ixx plus Iyy, you are going to get the polar moment of inertia. And this is the centroidal axis. Remember, Xx and Yy is passing through the centroid of this weld. Now coming to the whatever the torsional shear stress, PE into R by IP. Now resultant stress is nothing but the, using the parallelogram rule of law, you are going to get root over Q1 square plus Q2 square plus 2Q1 Q2 cos theta. Now this resultant stress should be less than or equal to the weld design strength. And as per IS 800-2007, this weld design strength is given as Fu by root 3 gamma MW. Fu is the ultimate strength. So in this way, whatever the load which is acting at an eccentricity E is going to be transferred through the weld. And this is the check you have to do if it is in plane eccentric connection of the weld. So thank you for watching this video. If you like my content, please like the video and also share with your friends, and don't forget to subscribe my channel. Thank you.